Welcome to solverfy.
We are given the generating function for a sequence. We are asked to find the generating functions for other sequences. We're told that the generating function for the sequence AK is the function g of x. And since g of x is the generating function, it follows that g of x is equal to the sum from k equals 0 to infinity of ak x to the k. In part A, we're given the sequence 0, 0, 0, A3, A4, A5, and so on. So this is the same sequence as AK, except for the first three terms are 0. So if we call the generating function for this sequence h of x, and this is going to be the sum from k equals 3 to infinity of a sub k x to the k, and this is equal to the sum from k equals 0 to infinity of a sub k x to the k minus a sub 0 minus a sub 1 x minus a sub 2 x squared. And we have that by definition this is equal to g of x minus a0 minus a1x minus a2 x squared. And this is the generating function for this new sequence. In part B, we're given the sequence a0, 0, a1, 0, a2, 0, and so on. If h of x is the generating function for this sequence, we see that it has the form sum from k equals 0 to infinity of a sub k x to the, and here we have that k is 0, this is x to the 0. If k is 1, this is x squared, so this is going to be x to the 2k. We have that this is equal to the sum from k equals 0 to infinity of ak x squared to the k, and this is by definition equal to g of x squared. In part C, we're given the generating function 0, 0, 0, 0, a0, a1, a2, and so on. If h of x is the generating function for this sequence, then it has the form sum from k equals 0 to infinity of, and we see that we have ak, and we start at x to the k plus 4. This is equal to x to the fourth times the sum from k equals 0 to infinity of ak x to the k, which by definition this is going to be x to the fourth times g of x. Part D, we're given the sequence A0, 2A1, 4A2, 8A3, 16A4, and so on. If h of x is the generating function for this sequence, then it's equal to the sum from k equals 0 to infinity of a sub k and 2x to the k. This is equal to the sum from k equals 0 to infinity of 2 to the k, ak, x to the k. Maybe that's what I should have written. So we notice, though, from this equality, this is the same as g of 2x. In part E, we're given the sequence 0, A0, A1 over 2, A2 over 3, A3 over 4, and so on. We're told that, as a hint, we should use calculus. So if h of x is the generating function for this sequence, this is going to be equal to the sum from k equals 0 to infinity of a sub k x to the, this isn't just a sub k, but a sub k over k plus 1. It's a little bit confusing looking. I'll write it this way. Times x to the k plus 1. And to this is a0 over 1 times x plus the sum from k equals 1 to infinity of ak over k plus 1 x to the k plus 1. So this becomes, if I differentiate, a0 plus the sum from k equals 1 to infinity of a sub k over k plus 1 times k plus 1 x to the k, and this simplifies to a sub k x to the k, and we have that a0 is the same as a0 times x to the 0, this is the same as the sum from k equals 0 to infinity of akx to the k, which is simply equal to g of x, and therefore it follows that h of x is the antiderivative of g of x. In part F, we're given the sequence A0, A0 plus A1, A0 plus A1 plus A2, A0 plus A1 plus A2 plus A3, and so on. If h of x is the generating function for this sequence, then we have that h of x is going to be equal to the sum from k equals 0 to infinity of the sum from m equals 0 to k of a sub k times x to the k And notice by the definition of multiplication of generating functions, this is equal to the sum from k equals 0 to infinity of a k x to the k times the sum from k equals 0 to infinity of x to the k since the coefficient here is 1. And this is equal to g of x times, and we have by theorem this is 1 over 1 minus x, and so we get g of x over 1 minus x.